Hello, algebra students. We are in section 8-7 and we're talking about factoring special cases today. What I'd like for you to be able to do by the end of this lesson is to be able to factor perfect squares and differences of squares. So let's get into some definitions and then you're going to see some patterns with these problems. So it says any trinomial of the form ax squared plus 2ab plus b squared, or ax squared minus 2ab plus b squared, is and we are going to say a perfect square trinomial. Now this is going to be called a perfect square because our two parentheses, or our two binomials that we make, are going to end up being the same. So when you have a perfect square, the first and last numbers are going to be perfect squares, like 25 or 64. So notice how those numbers are even squares. And then the middle number is going to be twice the product of one factor from the first and one factor from the last. So you're going to see what that means here in these next examples. All we're doing is factoring these. And notice that we have a leading coefficient of 1. So this is going to be a bit quicker, where I'm looking for things that multiply to 9 but add to the middle. So some things that multiply to 9 are 1 and 9, or 3 and 3. Well, 3 and 3 add to 6. So I'm going to have, I'm just going to rewrite this as x squared plus 3x plus 3x plus 9. And now I look at this as the front half and the back half. And for these first two terms, I can pull an x out, and I'm left with x plus 3. And then for these next two terms, I can pull a positive 3 out, and I'm left with x plus 3 again. Now notice what happens when we rewrite. We have x plus 3 for our matching parentheses. So I'm going to factor that out, and I get x plus 3 for my first set. But then I also have x plus 3 right here as well. So I'm going to have another set of parentheses that is x plus 3. So this is what makes it special. It's a double of this. So we're going to have the same thing in both of the sets of parentheses when we have this special type of problem. So let's do that again here. We're looking for things that multiply to positive 36 but add to negative 12. So some things that multiply to positive 36 that also add to a negative number would be negative 1, negative 36, negative 2, negative 18, negative 3, negative 12, or negative 6, negative 6. So we know we need to use our negative 6 pairing. So let's rewrite the middle term as that. So I have x squared minus 6x plus 36. And now we're just going to divide this into two halves. So for this part, I can pull an x out of both of those, and now I have x minus 6 remaining. For this back part, because this leading term right here, this negative 6x is negative, I need to pull a negative out, so I'm going to pull minus 6 out. But when I do that, I still get x minus 6 left over there. Look at what's happening. We have matching parentheses, so I'm going to pull that pair out. So I have x plus 6 for my first, or x minus 6, sorry, for my first set of parentheses. So I factored that out, and I factored this out. But what have I not factored out yet? Well, I haven't factored out this x, and I haven't factored out this minus 6. That's going in the next set of parentheses. Once again, it's matching. We're also using that same pattern we found in previous notes, where once you find your number pairing, so for example, we found our number pairing here and here, this minus 6 and this minus 6 is how we filled in the parentheses, just like what we did with the 3's. So let's do the shortcut for example C. I'm looking for things that multiply to 49, but also add to negative 14. So some examples might be negative 1, negative 49, or negative 7, negative 7. I'm going to use negative 7, and because I know about that shortcut now, I can just put in my two sets of parentheses, put an x at the beginning of both of them, and then fill in the parentheses with my magic pairing numbers, which is -7, -7. So fill it in and fill it in. So these are just a special case because it's the binomial repeated, but it's really basically still the same thing. It's not anything too crazy special. You might be able to, or you might want to sometimes write this condensed even more. So just so you can see it, you can write it as this. You could also write it as x minus 7 squared, like that. Because if I'm taking something multiplied by itself, I'm just squaring it. So we could condense it even more, just so you are aware of that. All right, so now we have one more special type, and this is called factoring a difference of two squares. Now there is a quick little pattern for this as well, but I'll show you the long version and then I'll show you the short version of this. So factoring a difference of squares is literally when you have a minus sign with two perfect squares. So a difference of squares is when you have two perfect squares getting subtracted. That's all this is. So, we are not used to seeing things with just two individual terms, but we could rewrite this, say example A. It says factor each expression. Let's look at example A. We could rewrite this so that it does have three terms. This could be written as x squared plus 0x minus 36. So now we got to ask ourselves, what's going to multiply to negative 36 but also add to 0? So if I have negative 36, some things that multiply to that are negative 1 and positive 36, negative 2 and 18, negative 3 and 12, negative 4 and 9, or negative 6 and positive 6. Notice how when we have negative 6, positive 6, if I add these two things together, it gets me to 0. But if I multiply these two things together, it gets me to this last number, which is what we've been doing. So what we can then do is rewrite this middle term, just like usual, as negative 6x plus 6x. But now let's split this up into two halves. So the first half, I've got x squared minus 6x. Okay, we're going to pull an x out of both of those. But when I factor an x out of both of them, I still have an x and a minus 6 remaining. What am I able to pull out of the back half now? So notice I have 6x minus 36. Well, I can pull a positive 6 out of both of those, but when I do that, 6x divided by 6 is still x, and negative 36 divided by 6 is still minus 6. So now that I'm ready to rewrite, this part in parentheses matches x minus 6 and x minus 6, so I'm going to pull that part out. And look at what's going to go in the second set of parentheses. I'm going to have x plus 6. So that's what's going to make this pair special. Because we have a positive and a negative, and the numbers are the same, it's going to cause the middle terms to cancel out and become a 0. So that's what makes this one special. We're not able to rewrite this one anyway because the two parentheses are not exactly the same. The two parentheses are just a little bit different. Alrighty. Let's look at the next pair, shall we? So we've got 4x squared minus 1, and we can rewrite that middle term, if we like, as a 0x. So I'm going to have 4x squared plus 0x minus 1. Now, if we're going to do this the long way, we cannot find multiples of negative 1 that add to 0. We need to find multiples of negative 4 because this leading coefficient is not 1. I have to take that 4 times that. So now I'm looking for things that multiply to -4 but add to 0. So -4, what are some things that multiply to that? Well, 2 and -2. So I can rewrite this middle term as 2 and -2. And so I'm going to have 4x squared minus 2x plus 2x minus 1. Let's factor the GCF out of each half. Looking at the part underlined in green, both of these have a 2 in common. I'm able to divide 2 out. They also both have an x in them, so I'm able to divide x out. Then I need to write what I have remaining. I'm going to have 2x minus 1. What am I able to pull out of 2x and minus 1? Well, I'm only able to pull a positive 1 out. So I'm going to write plus 1, but when I divide anything by positive 1, it's still that original thing. So I have 2x minus 1 here. Now it's time for me to rewrite. So I'm going to rewrite what I have in parentheses, which is the 2x minus 1. And then I'm going to have, so I've factored this part out and that part out. I have not taken care of this 2x, and I haven't taken care of this plus 1 yet. So now I have 2x plus 1 in the next set of parentheses. Now you might be noticing what we're doing here, or this pattern that we have going on. What we're doing is we are taking the square root of each part and then putting that in our parentheses with a plus and a minus. So let's do example C with that. So I'm going to have 2 sets of parentheses. And we're going to ask ourselves, what is the square root of x squared? In other words, what multiplied by itself will get me x squared? Well, x times x gets me x squared. Now, what multiplied by itself gets me 81? What is the square root of 81? That's going to be 9. So 9 is going at the end of both of my parentheses. And we know because this is a minus, I need 1 minus and 1 plus. That's the pattern that we've been following this whole time. We have minus plus, minus plus, minus plus, or plus minus. The order doesn't matter. But that's actually this little pattern that is up here in this table for you as well. So we can continue with that. Sorry, I'll box our answer in. Following that here. In example D, I have 16x squared minus 9. Put in your 2 sets of parentheses. And what multiplied by itself is going to get me 16x squared? What is the square root of 16x squared? Well, the square root of 16 is 4, so I know I need a 4 at the front of both of them. And the square root of x squared is x. Now I need to figure out what the square root of 9 is. The square root of 9 is 3. So that goes at the end of each of my parentheses. Now, because I need to keep following the pattern, I'm going to have a plus sign and a minus sign. The reason I need opposite signs is because when I distribute this back out, that will cause the middle term to cancel and become a 0. If they were both negative or they were both positive, they wouldn't be able to cancel. Remember, in order for things to cancel, they have to be opposite numbers. So I'm going to make a little note of that just to remind you. So, in order for numbers to cancel, they must be opposites. So that's pretty important. We've talked about that quite a bit in this class. Let's do the last example. I have 25x squared minus 1. I'm going to put in 2 sets of parentheses. And if I'm using that shortcut that we know about now, then we could say, okay, what's the square root of 25x squared? We'll break it down into its parts. What's the square root of 25? That's 5. What's the square root of x squared? That's just x. And now, what multiplied by itself gets me 1? Well, 1 times 1 equals that. And to continue the pattern, I'm going to have a plus and a minus. And that's all we've got for special cases. I hope you guys have a great night and to see you in class soon.